Fusion Mobile, quality e-learning experience on the go.
Yeah, welcome back to the class. The next topic we'll be talking about is captioned the arithmetic progression. We'll be talking about the geometric progression rather. You know, the last we did was the arithmetic progression, and I believe you've practiced that, and practicing that will help you flow in this class now. All right, for our clinic today, we'll be talking of geometric progressions. Okay. So the difference between your geometric progression and your arithmetic progression or series, okay, is that in arithmetic progression we add constants to the next value. Okay, so after the first term, a particular constant is being added into the first term to derive the next term of the series. But in geometric progression, okay, we multiply a constant term to the first term to get the next term of the series. Okay, so an example of a GP is this. An example of a GP series. Example of a GP series. Okay, you know, geometric progressions, or you can say GP. All right, is 1, 3, 9, and 27, 81, and so on. All right, so all you have to note here is that from the values we have, they note that each succeeding value, term or value, it is a multiple of a constant. Okay, just like we have above. The next value is 3. It's a multiple of 3 times 1 gives 3, and then a multiple of 3 times 3 again gives 9. 3 times 9 gives 27, and then 3 times 27 gives 81, and then the next term will be 3 times 81 to give another different value. Okay, these are things you need to note. Number 2 thing you have to note here is that a GP is of the form such that a, the first term, and then the next term is a multiple of a constant which you call r. Okay, and the third term is a multiple of double the constants. Okay, and the fourth term is a multiple of triple the constants, and so on to the last term is a multiple of the constant minus 1. Okay, minus the number of time replicated subtracted by 1, where arrow is the constant. Okay, where arrow is the constant term, and or what we call the common ratio. Okay, and a is the first term. A is the first term of the sequence, of the geometric sequence. Is the first term of the geometric sequence. Okay. Alright, just like your arithmetic sequence, you have to state some formulas for finding the last term and then the sum of geometric sequence. Alright, for finding the nth term of a GP, okay, could be found using the formula AR raised to power n minus 1. Okay, you know what A denotes, and then the sum of a GP. Okay, the sum of a GP is given as xn, which is equal to there are 2 formulas for this. Okay, all over 1 minus r. Alright, this is provided that r is less than 1. This is used when r is less than 1. Okay, you can use the sum xn to be equal to a into r raised to power n minus 1 all over 1 minus r. Okay, good. We can use r minus 1. Okay, this we can use if r is greater than 1. Okay, good. So the first one we'll use when r is less than 1, and then the second one we'll use when r is greater than 1. Okay, there are some to infinity series, okay, or what we call sum of infinite series of a GP, sum of infinite series of a GP, sum of infinite series of a GP is given us xn to be equal to a into 1 minus r. All right. Okay, so having been given these formulas, we can go ahead to determine and to resolve equations involving geometric progressions. All right. So assuming we are given the first example, we go for example 1. For our example 1, we are told to find the sum of the series. Find the sum of the series 8 plus 4 plus 2 plus 1 plus half. Okay, find the sum of the series of this series. Good. All right, the series is made up of 5 digits. We have 1, 2, 3, 4 and 5. All right, so we find the sum xn. All right, before we xn, yeah, let's define xn. All right, what makes us define xn is finding r. Then if r is greater than 1, then we would know what to do. Okay, you look at this series, you find out that r here is equal to, because the difference between the first and the next digit is dividing the next digit by 8. Okay, and then the difference between 4 and 2 is dividing 4 by 2. Okay, to find the difference, this gives 1 over 2. Okay, all right, and this gives 2 over 4 gives 1 over 2 2. Okay, I just hope you understood what I just said. All right, let me try to make it simple. You see, if you have a geometric series like 2, 4 and 6 and 2, 4 and 6, sorry, 2, 4, 8 and 16. Okay, to find the difference between these is saying 4 over 2, all right, and then 8 over 4. You know, 8, the difference between 8 and this, and then the difference between 2 and 4 is 6. Okay, the difference between 8 and 4 is 6, and then the difference between 8 and 16 is 16 divided by 8. Okay, you find out that this gives us 2. Okay, this gives us 2 2, and this gives us 2 2 as a common ratio. I think that's what I'm trying to do. And then this is not an exception where we have 8 4 2 1 and half. Okay, so the difference between 8 and 4, just like we had here, is 4 over 8, because, and then the difference between 4 and 2 is 2 over 4, and then the difference between 2 and 1 is 1 over 2. And so when we carry out the divisions, you have 1 over 2 here, and then you have 1 over 2 at this point 2, and then you have 1 over 2. So this 2 gives us 1 over 2. Okay, so I hope you now understand. And this difference, if you see that they remain constants throughout the divisions, and so we call them the common ratios. And so therefore the common ratio for 8 4 2, okay, the common ratio for the sequence r is equal to 1 over 2, and the first term there, a, is equal to 8, and then we find the sum of the sequence, xn. Observe very well that the common ratio r is 1 over 2, therefore r is less than 1, and so we'll use xn to be equal to a into 1 minus r raised to power n all over 1 minus r. Okay, and so the sequence has 5 terms, and so we are finding for x5. Okay, which we say it's equal to a is the first term 8, and then 1 minus r is 1 over 2, and then n is 5, and then divided by 1 minus r, where r is 1 over 2. Okay, and so we continue our computations. This is equal to 8 into 1 minus 1 over 5 raised to 1 over 2 raised to the power 5 is as good as saying 1 over 2 raised to the power 5, because anything 1 raised to the power anything still remains 1, and so this becomes 1 minus half. Okay, 1 minus half. Okay, which if we carry the LCM, have 2 minus 1, and then you have 1 over 2 as the denominator. So we can, over to this slide, we have 8 1 minus 1 over 5 2 raised to the power 5. When 2 is raised to the power of 5, we have 32, and so this is 1 over 32. All right, and then this gives us 1 over 2. All right, 8 in the bracket of 1 minus 1 over 32. You can do that finding the LCM and then carrying out your mathematical operations, and then it gives you 31 over 32. Okay, all over 1 over 2. And from this point we have 8 times 31 to give us 248 over 32. 248 over 32, and all over 1 over 2 too. Okay, so over to the next slide, we have 248 over 32. Okay, also being divided by 1 over 2. So we can convert this to fractions, to multiplication, and it becomes 248 over 32. Okay, divided by 1 over 2, which turns out to be 248 over 32 times 2. Okay, you can take care of 32, and it gives us 16, right? Gives us 16, and so we have 248 over 16, right? So when we divide 248 by 16, we have 15.5. 15.5. All right, so therefore the sum of the progression, therefore the sum of the GP, okay, will be equal to 15.5. That's when we sum it. All right, we take some other examples, and then we go ahead. All right, let's take more examples that seem somehow logical too. Example 2. Example 2. Let's say if the fifth term of a GP, is 162, and the fifth term, and the eighth term is 4374. all right, so we're told to find the series for the same series. Okay, for the same series, we have to find the 10th term. Find the 10th term and the sum of the 10th term. All right, and the sum of the 10th term. I think after this example, we'll end the class here. And so the solution follows that. Solution follows like this. Solution here we're told that the fifth term is 162. All right, for finding n terms of a GP, we defined the n term of a GP to be equal to AR n minus 1. Okay, where A is the first term, then R is the common difference, and then N is the number of terms we are looking for. And so for the fifth term, Tn for the fifth term, okay, right, that's T5 is equal to A, we don't know A, R, we don't know R, but we know the fifth term is 5 minus 1, and so therefore T5 is equal to a r raised to power 4. Okay, and then I'll call this my equation 1. Okay, and then for the 8th term, that's t8 will be equal to a r 8 minus 1. Okay, so that t8 is equal to a r raised to power 7. All right, I can call this my equation 2. That's fine. All right, you know that from the equation, t8 t5 is giving us 162, and then t8 is giving us 4374. Okay, so therefore my equation changes to this. 162 is equal to a r raised to power 4, and then t8, which is 4374, is equal to a r raised to power 7. Okay, so I can rewrite as a r raised to power 4 is equal to 162, and then a r raised to power 7 is equal to 4374. Okay, so this is my equation 1, this is my equation 2. All right, and so we try to resolve the two equations. To find out the value of it. And I think the easiest way of solving this is by solving by substitution, simultaneous equations by substitution. And so from equation 1 we can make a the subject of formula from 1. Okay, making a the subject of formula, a the subjects of formula. Okay, we have that a r raised to power 4 is equal to 162, so that a is equal to 162 over r. Okay, and I call this my equation 3. Okay, and so I'll substitute my equation 3 in equation 2. Substitute 3 in equation 2. Okay, and so in equation 2 we have a r raised to power 7 is equal to 4374. Okay, and where a is 162 over r, okay, times r raised to power 7 is equal to 4374. Okay, 162 over r raised to power 4. Okay, so r4 can take care of r7, and so we have 162 r3. Okay, because 4 cancels out 4 r's, and 7 will have 3 r's remaining. Okay, all right, so that 162 r3 is equal to 4374. Okay, so that r cubed is equal to 4374 all over 162. Okay, we'll carry out this divisions. That is 4374 divided by 162. You will have 27. That r cubed is equal to 27, and so r will be equal to cube root of 27. Okay, cube root of 27, r is equal to the cube root of 27 is 3 raised to the power 3. Yeah, that's right. And so the cube root of 3 raised to the power 3, so that the powers can cancel out the roots, so therefore r is equal to 3. For if you are confused at this point, please go back to indices. And get yourself cleared. All right, so therefore r is equal to 3, and so we go back to our equation 3 and substitute r. So we go back to equation 3. Okay, and substitute r to be equal to 3, and so equation 3 states that a is equal to 162 over r raised to power 4. A is equal to 162 over r raised to power 4. Okay, which implies that 162 where r is 3 raised to power 4. Okay, 162 over 3 raised to power 4 is 81. Okay, we mean 3 raised to power 4, which is 3 times 3 times 3 times 3 into 4 places. Okay, so 162 divided by 81 will give you 2. Okay, so therefore for this equation, r is equal to 3 and a is equal to 2. All right, so the next question there says find the series for the same series, find the 10th term and the sum of the 10th term. Okay, so for this same series, find the 10th term and the sum of the 10th term. I think the series a is equal to 2, okay, and then r is equal to 3. All right, so therefore the series starts with a, and then the next term is 2 times 3, 6. The next term is 3 times 6, 6, 18, and then the next term is 18 times 3, which is 54. Then the next term is 54 times 3, which is 162, and so it continues. Okay, so what would the 10th term be? Instead of going through these multiple multiplications, we can quickly find the 10th term by saying that T10 is equal to AR raised power n minus 1, where n is equal to 10. We have AR raised power 10 minus 1, which is equal to AR raised power 9. Okay, so therefore T10 will be equal to A is the first term 2, and then R is the common ratio 3 raised to the power 9. We know 3 raised to the power 9 is equal to 19683. Okay, so that's 2 times 19 times 2 will have 39,366. Okay, so therefore the sum of the 10th term itself is 39366. Okay, and so we are told to determine the sum of the first 10 terms, finding the sum of the first 10 terms, and the sum of the first 10 terms is given as xn, knowing that a is greater than 1, xn equal to, so what's the formula we have there? We have for greater than 1, we have a raised to the power n minus 1, then r minus 1. Okay, I've just reminded you we have that we're given that it is equal to a in a bracket of r raised to the power n minus 1 all over r minus 1. Okay, so which implies that a, which is 2, r raised to the power n, which is r raised to the power 9, okay, n minus 1, sorry, okay, let me use 10 minus 1, all right, all over r minus 1. Okay, where we know that r is 3, and then this is 3 raised to the power 10 minus 1 is 9, all over r minus 1. R minus 1 here is 3 minus 1. Okay, and so the sum of the first 10 terms will be equal to all right, that's a, and then that's right. Okay, and so we have 3 raised to the power 9 times 2. We have 3 raised to the power 9 is equal to 19683. 19683. Okay, all over 3. All right, and then as times 2 we have this to be equal to 39366 all over 3. All right, so therefore the sum of the first 10 terms is equal to 31322. Okay, xn, that's s10, this. All right, so with these illustrations, we've come to the end of this subject on geometric series. We've come to the end of this subject on geometric series. All right, Okay, let's take one more example before we close the class. Let's take one more example. Example 3. Okay, you're told to find the sum. Find the sum to infinity. Find the sum to infinity of the following series. Right, and we have 0.5 plus 0.05 plus 0.005 plus 0.0005. Okay, solution. The sum to infinity is given as the sum to infinity is given as follows. We check our previous equations. You find that we wrote out equations for the sum to infinity. All right, look at the sum to infinity. Xn is equal to a I minus r, 1 minus r. Okay, is given as xn equal to a over 1 minus r. Okay, and then looking at this the equation itself, a is equal to 0.5, and then r is equal to, I think I'll use the first term, the r is equal to 0.05 all over 0.5. all right, 0.05 divided by 0.5, and so it gives us 0.1. I can as well try the second and the third term. Okay, 0.005 divided by 0.05. okay, let me see what that gives. 0.005 divided by 0.05. okay, it still gives me 0.1. You can punch on your own calculators too and see the value that it produces. All right, so therefore we can say that r is equal to 0.1, and then the first term is equal to 5, and so therefore sum to infinity is equal to a over r, where a is the first term, which is equal to 0.5. okay, and then 1 minus r, okay, where r is 0.1, so we have 1 minus 0.1. okay, so this is equal to 0.5. 1 minus 0.1 gives us 0.9. all right, so 0.5 divided by 0.9 gives us this sum. Therefore x, and punch with your calculator, you have the value 0.5555555. so we can't take all these values at once, so we can take the 4 decimal places. You have 0.5556. all right, so this is the sum to infinity of this series. With this, we've come to the end of the class. Have a nice day. Bye.